Okay, here we're asked to multiply rational expressions, and we're looking at quadratics that have a leading coefficient of 1. So if I take a look, the rational expression is a polynomial divided by another polynomial. And if I look at these, I have this rational expression and that rational expression. And again, just like what we had done before, I'm going to take a look and I'm going to factor each one of these out. Now here, it's not a straight multiplication, right? Now I have a polynomial, so I need to factor the numerator and the denominator of each rational expression. So you can think of this as 4 factoring problems. I have to factor this first one, 4x plus 8. I have to factor the second one, which is x squared minus 3x plus 2. And then I'm going to factor the numerator of the second rational expression, and I'm going to factor the last one too. And then I'm going to rewrite this entire expression in terms of their factors. So let's start with number 1. We're going to look at 4x plus 8. So I have 4x plus 8. Let me just write all this stuff down here. 4x plus 8, if I want to factor that out, I look at each term and I see that I can pull out a 4, and I'm simply left with x plus 2. Okay, that was simple enough. Now if I look at the second one, I have x squared minus 3x plus 2. Now this has a leading coefficient of 1. So what should we think of? It's a quadratic. It's an x squared plus bx plus c. So we should think double bubble, right? So I can immediately go to the double bubble. And my variable is x. So I'm looking for factors of 2 that add up to negative 3. So you know that negative 2 times negative 1, right, multiplies out to be positive 2, and then negative 2 times negative 1 gives me a negative 2 plus a negative 1 gives me a negative 3. So these are my two factors, and I can just write them out here. Minus 2, minus 1. So now I'm done with the second, with the denominator. Let's work the third one. Again, it looks like we have a quadratic with a leading coefficient of 1, right? X squared plus x minus 6. Now I'm going to look for factors of negative 6 that add up to positive 1. I factor these. I have x, and I can think of, let's see, if negative 6 that add up to positive 1. So I know 3 times 2 gives me 6, right? But I want a negative 6. So one of these factors has to be negative, and one of them has to be positive. And this sign, because they have to add up to be a positive 1, my 3 is bigger, right? So my factors are 3 plus negative 2 gives me a 1, so that works. 3 times negative 2 gives me a negative 6. So my factors are plus 3 minus 2. Okay, home stretch. Almost there. So the fourth one, well, let's take a look at the fourth one. Right? That's not even, it's just x plus 2. I don't even have to do anything with that. That's just, that's already in its prime factored form. So now, let's go ahead and rewrite everything in terms of their factors. So here, instead of 4x plus 8, I'm going to write 4 times x plus 2. And then in my denominator, instead of x squared minus 3x plus 2, I'm going to write x minus 2 times x minus 1. Now I'm going to multiply that by this, this expression here, so I have x plus 3 times x minus 2, and then I simply have an x plus 2 down here in the denominator. I'm just going to put that in parentheses to remind me that that stays together. So now again I have a string of multiplications all the way across the numerator and then also in the denominator. So now I can just look for common factors between them and cancel them out. So I see right here I have an x plus 2, and down here in the denominator I have an x plus 2. And then, let's see, I also have an x minus 2 in the numerator, and I have an x minus 2 in the denominator. So now all I'm left with is a 4, an x plus 3 in the numerator, and an x minus 1 in the denominator. So my expression has been simplified to 4 times x plus 3 all over x minus 1. And that's my simplified answer.